Hi class, it's me, Professor Meyer. Just got to thinking that some of you may have never met me before. So this is me, this is my office. I'm glad you can't see it because it's really messy right now. But what I want to do is I want to create a video to show you an example of how seasons are created. And we're going to do that by using a bare bulb to represent the sun. And I've got a globe that I just happen to have in my office that will represent the Earth. And so I'm going to represent the four different seasons. So the vernal equinox, the summer solstice, the autumnal equinox, and the winter solstice. Okay, so let me get set up here. All right, there we go. Okay, so the first one I'm going to take a look at is the vernal equinox. Okay, the Earth is tilted 23.5 degrees on its axis, and on the vernal equinox, the sun's direct rays are directly over the equator. Okay, so equator, equinox, it makes sense. Another eq that we'll talk about here is equal hours of daylight and darkness. So pick a latitude, any latitude, and it will have 12 hours of daylight. Okay. Anywhere on the Earth, we'll have 12 hours of daylight on the equinox and 12 hours of darkness. So you have to take my word for it. On this side, it's kind of dark. Okay. So that's the vernal equinox. Okay. The sun is directly over the equator, and there are equal hours of daylight, 12 hours of daylight everywhere on Earth. Okay, so our Earth tilted 23.5 degrees. 3 months later, the Earth is going to be in this position, where the sun's direct rays are going to be over the Tropic of Cancer, 23.5 degrees north latitude. Okay, again, this is the summer solstice in the northern hemisphere. And the sun is directly over 23.5 degrees north latitude. Now you can tell better right here. So notice another cool thing about the summer solstice is any latitude above the Arctic Circle, which is 66.5 degrees north latitude, they're going to have 24 hours of daylight. Okay? So you go north of 66.5 degrees north latitude, and they're going to have 24 hours of daylight in the summertime, near the summer solstice. Likewise, if you go to the southern hemisphere and you go south of the Antarctic Circle, you're going to have 24 hours of darkness. Okay, so you're not going to get any direct light at latitude south of 66.5 degrees south latitude. Okay, so that's southern summer solstice in the northern hemisphere. Now this next one, the autumnal equinox. Okay, so another 3 months later, the Earth revolves around the sun. The sun's direct rays are back over the equator again. Okay, now I guess I can demonstrate the 12 hours of darkness. Okay, on the equinox, the sun, this is the autumnal equinox, the sun is directly over the equator. And there are equal hours of daylight and darkness, 12 hours of darkness, and then on my side now, 12 hours of daylight. Okay, that is the autumnal equinox. 3 months later, it is December 21st. Okay, this is winter solstice in the northern hemisphere. The sun's direct rays, okay, the sun is directly over 23.5 degrees south latitude, the Tropic of Capricorn. Okay. And so now the southern hemisphere is getting more direct rays. And in fact, if you go down to the Antarctic Circle, 66.5 degrees south latitude, those latitudes have 24 hours of daylight. Okay? And if you go north of the Arctic Circle, 66.5 degrees north latitude, they're going to have 24 hours of darkness. Okay, so no direct light north of 66.5 degrees north latitude in the summer solstice, during the summer solstice. So those are the relative positions, 4 dates that you really need to commit to memory. So March 21st is the vernal equinox, June 21st is the summer solstice, September 21st is the autumnal equinox, and December 21st is the winter solstice. Okay, always looking at it from the perspective of the northern hemisphere. So, all right. So hopefully that gives you an idea. There will be more concepts that I'll draw for you to hopefully explain these relationships some more.